Hello and welcome to helpyourmath.com. In this video, we're going to look at various techniques for simplifying trigonometric expressions, except for the very first examples where we're going to be unsimplifying because we're going to factor. We want to factor each expression, starting with sine squared alpha minus 1. So sine squared alpha minus 1, and this might look like one of the Pythagorean identities and you would be correct, but that's not what we're doing here. It's asking us to factor. So how could we factor this? Well, what does this kind of look like? Does this look, think back to algebra, and it kind of looks like x squared minus y squared. It looks like a difference of squares. Differences of squares will factor into root minus root times root plus root, and that's exactly what we want to do here. So this is going to factor into root of sine squared would be sine of alpha, minus root of 1 is 1, times sine of alpha plus 1. And that's it. That's all we can do. It asked us to factor, and we did. Okay, how about this one? We have cotangent squared alpha minus 5 times cotangent of alpha minus 24. And if this looks really scary to you, take a deep breath. Let's figure out a way that we can make this less scary. Let's change cotangent squared to x squared. And what does it look like if we do x squared minus 5 times x minus 24? That's much more reasonable, right? So we're going to pretend that this is what we're really looking at, and we're going to factor this. This is going to factor into, let's see, target product is negative 24, target sum is negative 5. How about negative 8 and positive 3? Those multiply to negative 24, they add up to negative 5, so it would be x minus 8 times x plus 3 is how we would factor this. How does that help us over here? Well, now we're going to go back to replacing x with cotangent. So we would have cotangent of what? Cotangent of alpha minus 8 times cotangent of alpha plus 3. And thus we factored it. Hooray! In the last example with factoring, wait a minute, what? We have cosecant squared but cotangent in the middle. So we can't use x squared and x because those are two different trig functions. Uh-oh. We need something else. We can always fall back on our Pythagorean identity. So how can we rewrite cosecant squared in terms of cotangent? Well, cosecant squared is the same as 1 plus cotangent squared beta. So we're actually going to use substitution here to rewrite cosecant squared, so that way we have the same trig function that we're dealing with. Okay, so what does this give us? This gives us 1 plus cotangent squared beta plus 6 times cotangent beta plus 8. Okay, so now wait, we have like terms. We have 1 and 8. So this would be 1. Now let's put this in order of, we'll put the cotangent squared beta first. So cotangent squared beta plus 6 times cotangent beta plus 1 plus 8 is 9. Okay, so again, if you're freaked out by the cotangent, just replace it with something else. So we can use x again. We could say that this is x squared plus 6x plus 9. And how would we factor x squared plus 6x plus 9? That would be x plus 3 times x plus 3, or x plus 3 squared. So we're going to write this as cotangent of beta plus 3 squared. And I'm sure if you wrote it as cotangent of beta plus 3 times cotangent of beta plus 3, that's totally fine as well. So this has been a look at factoring. Let's look at the operations next. In the first example, it looks like we need to distribute tan of x plus secant of x to tan of x minus secant of x. So tangent of x times tangent of x, that would give us tangent squared x. And then we would have minus tangent of x times secant of x. Then here we would have, I'm just going to put these in the same order, tangent of x times secant of x. And then we would have minus secant squared of x. If we combine the like terms, we have 1 tangent x secant x, negative 1, and this is positive 1, those cancel each other out. And we end up with tangent squared x minus secant squared x, which shouldn't surprise us that we ended up with the difference of squares, because that's exactly what we saw in the previous slide when we went from this form into factored form. That's what the differences of squares look like, right? Root plus root times root minus root. Okay, in the second example on this slide, it looks like we want to combine these, and we want to add these things together. How do we do that? We need a common denominator. So the common denominator that we want to use is going to be, we need one factor of 1 plus cosine of a, and we need one factor of sine a. So I'm going to multiply this fraction by sine of a over sine of a. And I'm going to multiply this fraction by 1 plus cosine of a times 1 plus cosine of a. And then I'll be able to have my common denominator, which would be this. And what's in the numerator? Well, sine of a times sine of a is going to be sine squared of a. Plus, and then I'm going to have two of these. Maybe I want to multiply this out. So that would give me 1 plus, and since this is the same factor twice, it's going to be the first term squared plus 2 times the product of the two terms in one of the factors plus the second piece of one factor squared. And then the denominator we have sine of a times 1 plus cosine of a. Oh boy. All right, how much cleaning up can we do here? So what I'm going to do is I'm going to rewrite the terms in a different order. So I'm going to have sine squared a plus cosine squared a, because this should jump out at you as equaling something else. Can you think of what that equals? That's one of the Pythagorean identities, and sine squared a plus cosine squared a is equal to 1. And we still have our denominator, sine of a times 1 plus cosine of a, and then we have 1 plus 1 is 2. I'm running out of space here. 2 plus 2 of cosine of a. That's going to give us sine of a times 1 plus cosine of a. And then, because we're not done yet, we can factor the numerator. The numerator has a common factor. Both terms have a factor of 2. So this would become 2 times 1 plus cosine of a over sine of a times 1 plus cosine of a. And then what do we notice? We have a common factor between the numerator and denominator that we can cancel out. So finally, in the end, what do we end up with? 2 over sine of a. That seemingly just combined the two, get the common denominator, turned into a whole big mess of a problem, didn't it? Okay, here are two examples. I encourage you to pause the video, try these two, and see how you do. Okay, if you started with the second one, that makes sense because it looks like it's going to be a little bit friendlier to work with. We'll go ahead and do that one. That way I can have all the rest of the page to write the first one. So this is, wait, what's sine squared theta plus cosine squared theta? That's just equal to 1. And then 1 squared is 1. That was so nice. Okay, what about the numerator? Or the top one. So for this one, we want to add. We have fractions, so we need a common denominator. The common denominator has to have any factor of each denominator. So I need one factor of 1 plus sine of a, and I need one factor of 1 minus sine of a. So this one needs a factor of 1 minus sine of a in the denominator, so I'm going to multiply that to both the numerator and denominator. And this one needs the factor of 1 plus sine of a. So that's going to give us, oops, I forgot about putting it up here, 1 plus sine of a. So we would have 1, let's try that again, 1 minus sine of a plus 1 plus sine of a, all over 1 minus sine of a times 1 plus sine of a. That would be, let's see, those cancel. So then we're left with 2 in the numerator over 1 minus sine of a, 1 plus sine of a. And if we wanted to, it's factored now and I don't see any common factors, so you could probably just leave it like this. If you wanted to get really fancy, you could distribute it out and you would have 1 minus sine squared a. You could get even fancier and write it as 2 over cosine squared of a. I don't think you need to do that. I think this is probably sufficient enough for this one. So that is a look at some operations with the trig functions. Now we're going to look at rewriting the expressions without fractions. So we have to figure out a way to get that 1 minus sine of alpha out of the denominator and how to get this cosecant of alpha plus 1 out of the denominator. All right, what are we going to do here? Well, we have a few options. One option is, looking at the numerator here, I could rewrite the numerator in terms of sine, right? And that way I would have sine and sine, so that's pretty good. How does cosecant squared of alpha relate to sine squared of alpha? Well, that's that Pythagorean identity that says sine squared alpha plus cosine squared alpha is equal to 1. So if I subtracted sine squared alpha from both sides, that would be equivalent to cosine squared alpha. So that would be 1 minus sine squared alpha over 1 minus sine alpha. We're so close here, but those don't cancel just yet. That numerator, though, that's a difference of squares. So we can write that as 1 minus sine of alpha times 1 plus sine of alpha over 1 minus sine of alpha. And lo and behold, look at that. That factor cancels with that factor up there, leaving us with 1 plus sine of alpha. And we followed the directions. We rewrote it without a fraction. So that's how we would do that. What about the second one? Do you want to pause the video and try it on your own? How'd you do? Okay, so we need to get this cosecant of alpha plus 1 out of the denominator. I might just try the same thing that we did last time, right? So cotangent squared, how can we rewrite cotangent squared? So the identity that we know and love is 1 plus cotangent squared alpha is equal to cosecant squared alpha. So what I could do is I could subtract 1 from both sides, and then that would be something set equal to cotangent squared alpha that's related to cosecant squared alpha. So I like that. So I'm going to rewrite this as cosecant squared alpha minus 1 over cosecant alpha plus 1. What do you notice about that numerator? That numerator is a difference of squares. So it's going to be root minus root times root plus root, all over cosecant alpha plus 1. Now look, we have a common factor between the numerator and denominator. We're getting rid of that fraction once and for all, and we end up with cosecant of alpha minus 1. These have been examples of the operations and factoring with trigonometric expressions. Thank you for stopping by.